Estimation of HCl by potentiometric titration. Aim: to estimate the amount of HCl present in the given solution using strong base by potentiometric titration. Apparatus: potentiometer, saturated, calomel electrode, pH electrode, burette, glass rod, beaker. Chemicals required: HCl solution 0.1 N, NaOH solution, distilled water. Principle: when a solution of strong acid HCl is titrated with the solution of strong base NaOH, the change in pH will be reflected in the change in EMF. When a small amount of alkali is added to the acid, a little change in the EMF is produced in the beginning. This change in electrode potential depends upon the fraction of hydrogen ions removed. As an equivalence point reaches, the fraction of the hydrogen ions removed by a constant volume of standard alkali increases rapidly, thereby causing a rapid change in the EMF. Thus, if the EMF of the cell is plotted against the volume of standard alkali added, a curve is obtained. As the changes in EMF is much more rapid nearer to the equivalent point, the exact equivalent point is obtained by differential method, where a graph of delta E by delta V versus volume of alkali is added, gives the maximum of the curve, which corresponds to equivalence point of the titration. HCl plus NaOH gives rise to NaCl plus H2O. Procedure: take 40 ml of HCl solution by using a measuring jar into a 100 ml beaker and dip the standard electrode, platinum electrode and reference electrode, pH electrode into a HCl solution and connect them to the potentiometer. Measure the EMF of the acid taken in the beaker initially by adding 1 ml or 2 ml of NaOH. For our convenience and for better readings, we are adding a 2 ml of NaOH solution and we are measuring the EMF for each addition. The EMF decreases gradually and then shows a sudden decrease in the EMF. Take enough readings after the sudden decrease in EMF and the range of endpoint is determined. Graph: a graph is plotted with the volume of alkali NaOH along the x-axis and measured EMF along the y-axis. A sigmoid inverted S-shape curve is obtained and the equivalence point is noted. To obtain a sharp endpoint, another graph of volume of alkali NaOH along the x-axis and delta E by delta V along the y-axis is plotted. The maximum obtained in the curve gives the accurate equivalence point. Tabulate the values of volume of NaOH and EMF, change in EMF delta E and change in volume of NaOH delta V and ratio of delta E by delta V to obtain a exact endpoint.
Estimation of HCl by potentiometric method, that is the experiment. The requirements for the experiment is digital potentiometer, one calomel electrode, one platinum electrode. This is a calomel electrode and this is the standard platinum electrode. These two electrodes are used, and the apparatus required are measuring cylinder, burette stand, burette and two beakers. Okay. So first we have to start the procedure by taking 40 ml of HCL solution. So we have to take HCL solution and measure 40 ml of HCL solution. This is the 40 ml HCL solution is measured and it is taken in a beaker. Into this beaker we have to place the electrodes. 40 ml HCL. This digital potentiometer is connected with the two electrodes. Okay. By using the wires we have to connect these two electrodes to the potentiometer and we have to standardize this potentiometer. Okay. After connecting the two electrodes we have to switch on the potentiometer. Then we have to put these two electrodes from the water into your HCL solution. We are placing platinum electrode and calomel electrode into the HCL solution and we are connecting it to the digital potentiometer. Two electrodes into the digital. After placing the two electrodes into the HCL solution, we have to note down the initial EMF reading from the potentiometer. So initial EMF value, EMF means electromotive. So into the burette we have to fill NaOH up to the mark. Up to 0 we have to fill it with standard NaOH solution. Okay. Without adding any NaOH solution, we have to first note down the EMF value from the digital potentiometer. So in the tabular form we have to note down at 0 ml NaOH. That is, we are not adding any NaOH from the burette. So we have to take 0 ml of NaOH. At that reading we got 0.09 EMF. This is the initial value of the EMF which we have to note down from the potentiometer. Okay. Then by adding 2 ml of NaOH from the burette, again we have to note down the EMF value. Slowly we have to add the 2 ml of NaOH and we have to mix the solution with the electrode slightly. Then we observe a change in the EMF value. EMF value will slowly decreases due to change in potential of the H plus ions. So again we got 0.088 from 0.09 to 0.088. The value of EMF decreases. Again we have to add 2 ml of NaOH from the burette. Next reading at 4 ml. Again 2 ml we have to add, slightly rotating the electrodes. Again we have to note down the EMF. Now it is 0.087. Again add 2 ml of NaOH from the burette. So it is now 0.086. So at 0 ml we got 0.09. By adding 2 ml the value decreases. Again for 2 ml, that means at 4 ml, at 6 ml, at 8 ml you observe a decrease in the EMF value. Like that we have to add 2 ml of NaOH each time, and we have to note down the EMF readings. At some point you will observe sudden decrease in the EMF. So now we are adding again 2 ml of NaOH from the burette, and we will note down the EMF value. See, you will observe a very difference, 0.056. So you observe a much difference between the two values. So there will be a sudden decrease in the EMF by adding this 2 ml. Okay. Again add 2 ml from 8 to 10. So now the value is 0. Zero point 0.021, 0.022. Like that, by adding 2 ml each time, you have to note down the EMF readings. That is the experiment procedure. So, starting from the initial value is the 0 ml NaOH, you got 0.09. By adding 2 ml each time, the value slowly decreases. At some point, you will observe a high difference between the value, that is the sudden decrease in EMF you will observe. That is the end point. And after the end point also, the value slowly decreases. At that point, you can stop adding NaOH from the burette. So, with these values, you have to draw a graph between the x-axis and y-axis by taking volume of NaOH on x-axis and EMF value on the y-axis. So, this is 0, 1, 2, 3, 4, 5, 6 like that, 1 ml each time of volume of NaOH and EMF readings on the y-axis. By taking all the EMF values, initially the EMF is high, slowly the value is decreasing, right? So by noting down all the points, at one point there you observe a sudden decrease and again also slowly decreases. By joining all these points, you will get a graph like this, inverted S shape or Z shape graph you will observe. This sudden decrease point will be your end point. That point you have to note down the volume of NaOH as the end point. Okay, this is the first graph we have to draw by taking volume of NaOH on the x-axis and EMF values on the y-axis. Now we have to confirm the end point by drawing another graph, second graph, that is by taking volume of NaOH on the x-axis and delta E by delta V values on the y-axis. Delta E by delta values, how will you get means? From this tabular form. Okay, EMF values, from EMF values we note down delta E values. Delta E means change in EMF values. That is, if you consider this as EMF 1, 2, 3, 4 like that, delta E values will be E2 minus E1. The first value will be this minus this, E2 minus E1. Second value will be E3 minus E2. Third value will be E4 minus E3. This value minus the above value. Like that you will get delta E values. Delta V means change in volume. Here change in volume is 2 ml each time. 2 ml each time. So you have to divide with 2 every time. So delta E divided by delta V you will note down in the last column. By taking these delta E by delta V values on the y-axis, you have to draw the graph. That graph you will observe like this. You will get like this. By noting down all the points of delta E by delta V, you will get a peak like this. By joining all these points, you will get a highest peak. This highest peak point is your end point value. The value what you got here,
we can obtain, which is 6 ml, is the equivalence point from the both the graphs.
will be equal to 3 ml. You may get 4 ml or 5 ml. Here I am taking 3 ml. So you have to note down the volume of NaOH from the graph and substitute that value in your formula. N1V1 equal to N2V2.
Where Nt is the normality of NaOH, which is 0.1 N, and V2 is the volume of NaOH solution, which is obtained from the graph, which is 6 ml, and V1 is the volume of HCl, which is 40 ml, and the normality of HCl is obtained by substituting the values of N2, V2 and V1, and we can obtain the value of N1 is equals to 15 into 10 power minus 3 N, and the amount of HCl present in 1 liter is equals to N1 multiplied by 36.5, which gives rise to 0.5475 gram. Result: normality of given HCl sample is equals to 15 into 10 power minus 3 N, and the amount of HCl present in the given sample is equals to 0.5475 gram per liter. Thank you for watching. Please like, share and subscribe if you like.